Hello everyone, my name is Kalindi. Let's go through what I studied in Java this second week. Let's go over the algorithm and problems section first. In week 2, I solved problems which involved the use of pointers. The first two problems, which is valid palindromes and reverse string, involved the use of two pointers, left and right pointer. There is a while loop which checks the condition that left is always lesser than right. And the second type is of linked list. The first problem in that type was of reverse linked list. I was able to reverse the linked list using iterative approach, but when it came to recursion, I got stuck. After looking at the solutions, I was able to solve the problem using recursive method and a tail recursive method. In recursive method, they apply the recursion first, and while backtracking, they reverse the linked list. And in tail recursion, we reverse the linked list first and then recursively approach forward the linked list. In the next one, middle of the linked list, we use again two pointers, fast pointer and a slow pointer. These were all the problems that I solved, and I'm pretty confident in all of them now. One more additional point for the 10th problem is that in tail recursion, I learned that Java doesn't apply any optimization for it. The reason for it being Java prefers security and debugging ability over the small performance gain which this tail recursion optimization will provide. Moving on to the theory part, I studied the remaining chapter 2 of concurrency in practice. I also did revision of what I studied first. I revised the need for multi-threading, the advantages and risks associated with it. The advantage being that same memory address is shared among multiple threads of the same process. So the same heap and objects are used by multiple threads. This is an advantage, but it also has risk with it. The risk being data inconsistency if multiple threads access the objects in an uncontrolled manner. So to address this risk, we control the access by using synchronization. But if synchronization is not properly applied, we face liveness failures. The types of liveness failures are deadlock, starvation, live lock. While there are many benefits for multi-threading, performance benefits, if it is not done properly, CPU will spend most of its time doing context switches and scheduling instead of running the actual application. And if synchronization is applied too many times, it will affect compiler optimization, which is necessary for faster performance. I also studied the pros and cons of asynchronous workflow versus synchronous workflow. Asynchronous workflow uses non-blocking I/O operation, while synchronous workflow uses blocking I/O operation. The meaning of this is when a thread is requesting for an I/O operation in asynchronous workflow, it is not kept waiting, it is not blocked. It can continue its program flow, and when the I/O operation is complete, the OS notifies the thread and the execution continues after that. And in synchronous workflow, when a thread is requesting for an I/O operation, it is kept waiting. And when the OS completes I/O operation over here, it notifies here too, and then the thread continues its normal execution. So the pros and cons of it is like asynchronous workflow code is complicated and it can lead to callback hell. But as the threads are not kept waiting over here, small amount of threads are required when using asynchronous workflow, and that is a benefit when we have to write applications which have scalability in them. In synchronous workflow, as the threads are kept waiting, so large amount of threads will be required when we need to serve large amount of requests. So scalability is an issue with synchronous workflow, but the code is simpler in synchronous workflow. Moving on, thread safety is not about code but protecting data from uncontrolled concurrent access. So it is more about data than about the code. Terms used in synchronization, which we'll study further in this book, are volatile, explicit locks, atomic variables, and synchronized keyboard. Next point, encapsulation and data hiding help thread safe class. So if we write clean code using object-oriented principles and solid principles, we are helping to form a thread safe class. Now the important terms which will be required later on. What is correctness? When a class conforms to a specification, it is correct. What are invariants? Constraints of a object state. So like if I am maintaining a counter which counts the request I get in a servlet, so its invariant will be that it should always be positive. It can't be -1, -2, -3 because I am not serving negative request. It can only add up or be 0. Post conditions, effect of the operations. So taking the counter example only, if I get one request, the counter will increase by 1. If I get two requests, it will increase by 2, and so on. Next point, what is a thread safe class? It behaves correctly when accessed from multiple threads, and we don't require to apply any synchronization from our end while calling its methods. Now, what is a stateless class? Stateless class is the one which doesn't have fields in it, and it is inherently thread safe as it doesn't have fields. As we already saw, thread safety is not about code but about data. So if a class doesn't contain any data, it is inherently thread safe. Servlets are mostly implemented with no state for this purpose. Next point, atomic operation. They are single indivisible operations. Compound operations. They are sequence of atomic operations, you can say. Types of compound operations include read, modify, write, which includes the counter example which we most commonly see in race condition examples. And second is check then act, which is lazy initialization type, and this is used in singleton pattern. Next point, race condition. So race condition occurs when the correctness of a class depends on the relative timing of multiple threads accessing that class at runtime. So if thread 1 and thread 2 come sequentially to that class, they get correct data. But if they come simultaneously, they are facing data inconsistency. That means that the class is not thread safe and we are facing a race condition because the relative timing of multiple threads is affecting the correctness of the class. Compound operation can cause race condition. So we use synchronization to avoid race conditions. So what does synchronization do? Synchronization converts these compound operations to atomic operations and which are visible across threads to prevent race conditions. So the compound operations which are performed in 2 to 3 steps are made to look as one step when we apply synchronization. Next point, while applying synchronization, when to use atomic classes and when to use sync keywords and locks. So example 2.4 and 2.5 tell us that clearly. When there is only one field in the class which needs a controlled access, we use the atomic classes. But when there are multiple fields in the class and whose combination is required to be atomic, we use synchronized keywords or locks. For example, let's say we have a class which has two fields, a number and second its factors. So when one thread comes and changes the number, it should also change the factors. If while changing the number, another thread comes and changes the factors, that will lead to data inconsistency because clearly the number and its factors are related to each other. So when updating number, that same operation should update its factors too. So this should be an atomic operation, not a compound operation. So to preserve state consistency, update related state variables in a single atomic operation. And that's what clears the first point. If I use atomic integer for the number and atomic reference for the factors, that won't give me any synchronization. So for that is when I use synchronized keywords and locks when I need to update multiple related fields in a one atomic operation. Next point, every Java object can act as a lock. That is called intrinsic lock. How can we acquire an intrinsic lock? When we enter a synchronized block or a method, we acquire the lock. And when we exit it, normally or via exception, we release the lock. So when a thread enters a synchronized block, it acquires the lock. And no other thread is allowed to execute the code unless this thread finishes the code. That's what makes the group of statement as a single indivisible unit. So that's what makes the compound statement or the compound action as a one atomic action. And that's what gives us thread safety. Next point, intrinsic locks are reentrant. So what does reentrant means? So like if my thread has acquired a lock to an object and it's calling its method, and later it needs to call another method of the same object, like of the same lock. So it doesn't need to acquire the same lock again. It already has the lock and so it can invoke that method too. So this saves us from deadlocks, and this is because locks are acquired on per thread rather than per invocation basis. So the lock maintains a thread and acquisition count. So if my thread calls one method of the same class, the acquisition count is 1. It calls another, it becomes 2. And as the thread leaves the method, the acquisition count decreases. And when it is 0, the lock is released. As we saw, thread safety is more about data than of code. So if I'm using a lock to coordinate access to a certain variable, that same lock must be used everywhere that variable is accessed. You can't use two different locks for it. That will again create data inconsistency. There is another point. If my thread has a lock of some object, that doesn't mean other threads can't access that object's field. There is no relation between the object's intrinsic lock and the fields it contains. So the object can be accessed by many threads, but the lock is owned by one thread only. This point is a revision of what we already studied. If multiple variables participate in an invariant, use same lock for each variable. So, if number and factors are related to each other, when I modify number, I should also modify factor in the same operation, in one atomic operation. So for that to happen, I need to use the same lock for both of them. This point is also a revision of what we already studied. Individual atomic actions, when they are combined, they become compound actions. And these can lead to race conditions. We need to make them as well atomic. What does poor concurrency mean? It means that when my requests are not getting processed because of the code I have written, like poor concurrency code that I have written, and not because of the processing unit my system has. Like my system has many processing units, but still my requests are not getting processed. That means there is a fault in my code, and that means I have poor concurrency in my application. Last point to avoid poor concurrency, you should avoid using locks when the operation is very long. Second book which I read was Modern Java in Action, Chapter 1. What's new in Java? First is behavior parameterization. First, we used to pass only values in our code. Now, it is possible to pass behavior as well. What do you mean by behavior? We can pass code, we can pass methods as a parameter to other methods. So that means making methods as first class citizens. So in Java language, Values used to be first class citizens and methods used to be second class. Now we are making methods first class citizens as well. Java 8 is making best of both OOPS and functional programming. So general rule when we pass around functions is that we don't access shared mutable state. That means all the variables should be local to the function and nothing from outside should be passed in it. Such functions are called pure functions, stateless functions, or side effect free functions. So why is this a general rule? That is because Stream API is built on this idea, parameterized behavior of its operation. So when using a stream, we always pass behavior as a parameter to it. And Stream was introduced to provide parallel behavior for free in Java. So for parallel behavior to be successful, the functions need to be stateless functions or pure functions or side effect free functions. So that is why it is a general rule that when passing functions here and there over Java, they need to be stateless. Introduction of Stream also brought a higher level of abstraction in our thinking. So like if I want a list of IDs of all the people objects, then I need to be thinking like this. Convert the stream of people into stream of IDs of those people. So I need to focus on what I want rather than how I need to get it. That is how we write SQL queries, and that's how we'll be writing stream functionality. So streams was one reason why we are passing behavior in Java. The other reason is simplicity. So if I want a method in another method, if I want a behavior in another method, I needed to wrap that behavior in an object and then send it as a parameter to that other method. But now I can send the method itself, and that brings simplicity to the code. And streams and behavior passing eliminate boilerplate code as we just saw, and easy parallel behavior because of stateless functions. Lambdas also avoid unnecessary code when passing line methods, single line methods. So one important point, collections are used to store data and access data. That hasn't changed. Stream is used to do computation on those data. So this simplifies the computations on these collections. The next new thing is interfaces now have default methods, and there is some portion of the chapter remaining that I'll cover in the next week. Third book which I read was Cracking the Coding Interview Chapter 2. That is LinkedList. First point in it was how do we make access to the head node of LinkedList thread safe. As we have already studied, encapsulation helps in thread safety. So we implement LinkedList class that wraps the node class. And that's how we make the head node thread safe. Then there is a point about runner technique which uses 2 pointers, and third point is always look out for cycles and null pointer when solving problems. That's all. I didn't solve any problems from this book, and I'll be doing that next week. Fourth I did was plural site lambda expression course revision, but I didn't revise the entire course. I just revised method references module from it, and I revised what are the types of method references, that is instance, static, bound and unbound. And sometimes method references reduce readability of the code. Why? Because to understand what a method reference is doing, we need to look at the functional interface it is implementing, and because sometimes it hides the parameters. So we need to check the functional interface it implements to know exactly what parameters it is taking and what it is returning. So that was it for the theory section. Third, points that require my attention. While reading the book, there was this point like main event loop or something like that, which I didn't understand. And I need to know what that is. so I'll look into it. And fourth is divide and conquer algorithms. I I had read one while solving, but I found it difficult, so I need to solve those. And there is also a fifth point, um, which is that I need to write the code on logs. I have just read the book. I need to write the code for it. So that that's it for the attention section 2. Next week, I'll be doing LinkedList remaining problems and some problems from cracking the coding interview too. And I'll be doing algorithms on stacks and queues. And I'll continue reading the books which I've mentioned I am reading currently. So let's meet the next Sunday. And till then, study.